Bismillah ar-Rahman Rahim. Today we'll be discussing abstract classes and abstract methods. So far we have discussed several aspects of object-oriented programming, but this one is also one of the feature of object-oriented programming, abstract classes and abstract methods. Okay, before going into the detail, first you need to know what is the abstract. Well, once you will know the definition of the abstract, then it will be quite easy for you to understand the concept of abstract classes and abstract methods. Abstract, basically you have planned something and it does not exist in reality. So that is the abstract. So I will relate this definition once we'll discuss the abstract classes and the abstract methods. Let's proceed. For example, as you can see, we have this class that is a shape. It has its own data members, width and height, but it has one of the function or the method get area. So we are not sure about the get area, what type of the input it will be accepting, and what uh, functionality it will perform, and what type of the result it will return. So we're not sure because the shapes can be of several different types. It can be a rectangle, it can be a triangle, it can be a square. So all these shapes have their different areas. So we're not sure about its functionality and what type of the input it will accept. Maybe input we may agree as the argument, as you can see there. We may know about the argument because we have defined two of the data members, width and height, so it can accept width and the height, but we're not sure about its functionality and its result, so all the shapes may be different. So does not seem like we have enough information to get the area. If all we know is it's a shape can have several different shapes. Okay, so what is the potential solution for this? What we do is just leave it for the subclasses. We'll be using the concept of inheritance while discussing the abstract classes and abstract methods. So what we do is we do not define any functionality of this method that we have seen in the previous slide. That was to find the area, and we leave the functionality without defining any functionality, and we leave the functionality for the subclasses to define their functionality as per their requirements. Because if there is a shape of circle, rectangle and triangle, so these are the inherited classes. They will be actually inherited by the shape class, and each subclass, circle, rectangle and triangle, they will define their own method and they will define their own functionality as well. So, but the important thing is uh, the method defined in the shape, that is the get area, should also be defined in all these classes. So we need to define them following the same signature or the same syntax. The method of that we have already discussed about the overriding thing. So it should override the methods in all these inherited classes. So just leave it for the subclasses to define their own functionalities as per their requirements. Have each subclass define the get area. But the important thing is the method defined in the shape. We're sure that there is a method that will be to find the area for all different types of shapes. We're sure about it, but we are not sure about their functionality, what type of functionality they will follow. For the circle, the area will be different. Rectangle, area will be different. Triangle, the area will be different. So each of the subclasses will define their own functionality, but the method name should be same. So they must have the same signature as defined in the parent class. So define the get area in the shape and simply return -1. We're talking about the shape class. We'll define this function get area and we'll return -1 because it's not doing anything. We cannot define a specific functionality in a shape. Subclass override the method with more meaningful behavior. So the important thing is the overriding. So in the overriding, you already know that whatever the methods defined in the parent class should also be defined in the child classes with the same signature. The important thing is, so whenever the class will be instantiated, and the instance will call their appropriate methods from the subclass. Let's proceed. So far we have not discussed anything about the abstract classes and abstract methods. uh, I'm just building up a scenario so that you can understand the basic problem, and then we'll devise a solution as per requirements. So fix with the dummy method, what you have done is the get area. You have defined this method and it is returning -1 in the class, parent class, that is shape. So what you have done, you have defined two objects of which class? Of shape class. And no, I'm going to actually instantiate or the two more objects from their child classes, and I have actually stored them into the two objects of the parent class, that is shape. So one of the child is the rectangle and another child is the triangle. The important thing is that these are the inherited classes of class shape. We have actually done this in the polymorphism lecture, as if you still remember it. So the question is, what happens if the subclass does not override a get area? What should be your answer? If a method get area is not defined into the child classes but it is defined in the shape class, so what will happen? Definitely the parent class object, when we'll call through the parent class object with the dot operation, and that we'll call this function get area. Obviously it will call its own function because there is no no method has been defined in the rectangle and triangle. It will give the priority to its own. But if it has been declared, it would have actually given the priority or the redirection toward the child class functions. Okay, let's move on. A better fix. We know we want to be able to find the area of objects that are instances of shape. The problem is we do not know how to do that. If all we know is it's a shape, because we're not sure about the functionality of a shape, what type the shape it is, until and unless we do not define the specialized class of a shape that can be rectangle or the triangle. So what we do, we define the get area as the abstract method. As you know, in the beginning I told you the abstract method, basically you have planned something or you're not sure about its functionality, and then you need to define it as the abstract method. So the get area should be the abstract method and must be defined with the term abstract in the parent class only, remember, not in the child class. But in the child class, we'll have to redefine those methods, and these methods will be following the same signature. So in that case, we'll be using abstract as a keyword. So in Java, whenever you write the abstract, it will be a keyword. We'll discuss it with more examples later on. Okay, so what we have done is making the get area as the abstract function. In that case, we have not defined actually as abstract method this get area. What we have done is to define this function name get area, but as you can see I have put a semicolon here. That means it does not have its own functionality, so it won't have its own body, right? Later on this function will be redeclared into the child classes, and that will turn the abstract, because we know the functionality, we know there is a functionality to get area, but we were not sure about its specific functionality, how the area will be defined for a specific object, for example triangle or rectangle. So methods that are declared abstract have no body. That is important. So whenever you declare, we have not declared it as abstract because we'll be using an abstract keyword and it will come right here before the return type and after this access modifier. Okay, so the important thing is whenever you will declare the abstract function, and we'll declare it in the parent class only, remember, and we'll define it with the keyword abstract here, and it will not have any body. The method that has been declared but not defined is an abstract method, right? The method has been declared but not defined. We have declared it, and we have not defined its functionality. It does not have its body. So that will be the abstract method. How we'll use it, we'll discuss it later on. But before moving on, it is important to discuss the rules of the abstract method in the classes. So the first rule is the abstract method do not have body. Rule number one. Whenever you define an abstract method with the keyword abstract in it, it should not have any body. And remember, it should be declared in the parent class only, like a shape. They have uh, they just have the method signature as shown in the previous slide, but the important thing is they should be having a same signature. If a class has an abstract method, it should be declared abstract. That is very important. For example, there is a class like a shape, and you have declared a method that is a get area, which is the abstract. So it is compulsory you declare that class as abstract as well. So whenever a class will have an abstract method, that class should be declared as abstract as well. The vice versa is not true. That means an abstract class doesn't need to have the abstract method compulsory. If you define a class as abstract, now it is not necessary you need to define an abstract method as well. But once you have declared abstract method, that class should be declared as abstract as well. If a regular class extends an abstract class, then the class must have to implement all the abstract methods. Now, the third point is very important. For example, in a parent class shape, you have declared get area as the abstract method. Now, when you will inherit the shape class to the circle or rectangle or the triangle, so it is compulsory that whatever you have declared abstract methods, it should be redeclared in a child class with the same signatures, plus they will have their own body. No, uh, it is compulsory for you to implement all the abstract methods that has been declared in the parent class. It should be redeclared in the child class as well. So you need to redeclare all of them, the abstract methods declared in the parent class. If you miss any of the redeclaration in the child class, then the compiler will give you an error. So all the methods declared in the parent class should also be redeclared, and redefined as well. It is only declared in the parent class, but they are not defined. We have not defined their functionality. But in the child class, it should be redeclared, and you need to define their functionality as well in the child classes. Okay, what is an abstract class? The superclasses are created through the process called the generalization. Generalization means uh, they do not have their specific functionality. We call it the generalization. And for example, a shape, that is a generalized class. And once you have inherited that generalized class with a specialized class, which is the triangle, because you have actually the specialization of that generalization class shape, that is the triangle or the rectangle. So the common features are factored out of the object classification. Those functions are formalized in a class. This becomes a superclass. The classes for which the common features were taken become a subclass to the newly created class. The only thing is that whatever you have declared, it should be redeclared in the child class as well, right? The same methods with the same signature as well. Often the superclass does not have a meaning or does not directly relating to the thing in the real world. It is an artifact of the generalization process. The only thing to focus on is the abstract class do not have a functionality, but the type of functionality should be defined in the abstract classes, because get area, that is the functionality. We know the functionality, but how that functionality will work, we're not sure about it. That's why we define it as the abstract in the parent class or the superclass. Because of this, abstract classes cannot be instantiated. This act as placeholder for abstraction. Now that is very important thing. A class that you have declared as the abstract class, which is your the superclass or the parent class, it cannot be instantiated. Reason being, you have declared it as the abstract class, So the abstract class can never have any specific functionality. So if you will try to instantiate it, it will give you an error because it do not have a specific functionality like a shape. It cannot be instantiated if you have declared that class shape as a abstract class because it do not have any functionality. So it is useless to instantiate that class. Though the compiler will not allow you, but it's not possible. Okay, there are a few rules for the abstract classes. Any class containing an abstract method is an abstract class. So we have already discussed that rule. If you have declared a class, if any of the class has the abstract method, that class should be declared as abstract as well. You must declare the class with the keyword abstract, as you can see right here. This is the access modifier that's public. Then there will come the abstract, and then the class is the keyword and the name of the class. It will have its model. An abstract class is incomplete. It has missing method bodies, right? Incomplete in the sense that the methods do not have their functionalities. They have just the prototype. You cannot instantiate. We have already discussed it. The few rules to the abstract classes: you can extend an abstract class. So abstract classes can be extended. Extend is the keyword. You already know. Later on, we'll be discussing about the interfaces. Interfaces and the abstract classes, they have similar kind of functionality, but their method to use interfaces and the abstract classes are different because the abstract classes are always extended, whereas the interfaces, they are implemented. And as far as the extended classes are concerned, in Java you can only extend one class, but in the interfaces you can implement more than one interfaces. So that is the basic difference between the interface and the abstract class, though their functionalities are common. Because in the interfaces only the prototype of the functions are defined and you need to redeclare them into your implemented classes or the child classes. Not in the child, it's not an appropriate word to use it, but it is behaving like a child. You use the functionality of the interface and you need to redefine it into the implemented class, whereas in the abstract, you define the abstract functions. They do not have their functionality, but whenever you will extend that abstract class into the child class, then you need to redefine those functionalities. So their functionalities are common between the interface and the abstract class, but their approach to use them is different. Another thing, interface, in the interface you have only the functions or the function prototypes, whereas but they do not have the instance data or the variables. But whereas in the abstract classes you can define the variables as well. So that is another difference between the interface. Later on we'll discuss the interfaces, and then I will draw the comparison between the abstract classes and the interfaces in more detail. So if the subclass define all inherited methods, abstract methods, it is complete and can be instantiated, right? That is the subclass. Subclass can be instantiated. So it should also redefine all the functions of the that has been declared in the abstract class. If the subclass does not define all the inherited abstract methods, its too must be abstract, right? So we have already discussed this. You can declare a class to be abstract even if it does not contain any of the abstract methods. Class can be abstract, right? If though it has do not have any abstract methods, but once you have declared any of the method as the abstract in a class, that class should be declared as abstract as well. That's rule. We have abstract classes. I won't go into its detail because I have a concrete example here. We'll discuss with the syntax. Abstract class syntax is like this. You define access modifier, abstract class name, and then within that class you have a one method. It will have definitely a specific return type. It will have the method name. It will be accepting some parameters and the semicolon. It should not have any body for as far as the abstract methods are concerned. So it has abstract method. That's why we have declared this class as abstract as well. There is a compulsion. A class can be abstract even if it has no abstract methods. We have discussed it already. Okay, defining abstract classes. As you can see, we have defined this class as the abstract class, right? It does not have necessarily any methods in it. So we are extended this class vehicle with the car and vehicle with the truck as well, and they have their own functionalities. If inheritance is not defined, the class extends a class called object. So by default, it will be called by the object, that is the default class defined in Java. Okay, more details. Example of the abstract class. No, you can see I have a class animal. It has two methods, eat and breathe. So the both of them has been declared as abstract, and once they are declared abstract, they won't have their body or the functionality. This class cannot be instantiated. So whenever you try to instantiate the animal class, it will give you an error. You cannot instantiate because you have declared the methods as the abstract methods. So there is no functionality in it. So there is no use to instantiate that class. Any non-abstract subclass of the animal must provide eat and breathe methods. Non-abstract classes that can be the subclasses. Okay, these are the details we have already discussed. I would like to come directly to the example of the abstract class. As you can see, we have a shape, and the shape being extended by the circle and the rectangle. And rectangle then again have a another subclass. So in that Java code, as you can see, we have declared a shape as the abstract class, right? In the abstract class, it has three different methods, maybe four. Two of the methods have been declared abstract, but two methods are not declared as the abstract methods. So these methods which have been declared as the abstract method, they do not have their functionality. So the point is can be if we cannot actually instantiate the abstract class. So what is the actually use of declaring these two methods that are not abstract? They have their functionalities as well, but what is the use? Can you figure it out? The answer is because this class will be inherited to the subclasses. So the subclass can use this functionality, the inherited class child, because the child class will have their own object, and through the child object we can access this functionality, but you cannot instantiate the shape class. Okay, let's move on. There's a problem. We are using the abstract classes, and in that abstract class there is a problem scenario. In that particular scenario, there will be a problem. Reason being, we have a class shape. This class shape is being extended to the star. It has a method draw, but this does not have a method draw, right? This is the shape class, that is the parent class. The parent class being extended to the star have its own method, that is draw, and crescent is another type of shape which is being extended by the shape class. It has a draw method as well, but the parent class do not have a draw method. So if you declare this particular object through the shape class, some shape, no, you are storing the object of a new star in this some shape. Can we do that? Yeah, this is legal because star is a type of shape, and through the inheritance this particular scenario is allowed. We have discussed it in the polymorphism. This is polymorphism. Okay, now through the parent object we are calling the draw function, right? So there is an error, syntax error, because some shape might not have the draw method, right? Some shape might not have the draw method because uh, you are calling a draw function. So if we have declared a shape in the parent class as well, and if we make it abstract, no, it will be compulsory for all the child classes to redefine that method. No, we are sure about it that we have declared abstract method here. It will be redeclared or redefined by the child classes as well. So in that case, that will be true. But right now in that scenario, we're not sure that the child will have a draw function. So that's the reason there is an error. Here's the solution. So in the uh, parent class, you need to define abstract function, that is draw. No, it will be compulsory for the child classes or the inherited classes to redefine that function, because if they don't define it, there will be an error. Whatever the abstract methods that need, there is a compulsion for the child classes to redefine them, right? The same happens with the interfaces as well. We'll discuss them later. Now, in that case, as you can see, the child object being stored into the parent object, right? Inheritance concept. This is legal because star is the shape. However, shape is equal to new of shape is no longer legal, right? You can define it through the shape, and is the new. This is no longer legal. Why it's no longer legal? Reason being, we have declared this class as the abstract class. The abstract class can never be instantiated, right? But this is the legal procedure. Through the parent object, we are calling a draw. No, we are sure this is legal because every actual instance must have a draw method. Instance mean the child classes. The child classes must uh, have to redefine the abstract method in their functionalities. So in the continuation, in the next lecture, we'll discuss about the abstract methods in detail. So far, we have discussed the abstract classes. See you in the next video. Thank you very much.